Hey everyone, welcome to Scalier, and this is Scale-1, the foundation layer of our DSS series called Scales. In today's video, we will take a simple problem, swapping two numbers, and look at 5 different ways to solve it. But more importantly, we will understand why each method exists and where it might fail. So grab your IDE and let's swap some numbers the smart way. So here we have created a class called swap two numbers. Let's write the main method. So here I'll define two variables a and b. A value will be 10 and b value will be 20. After creation of these two variables, I am just printing these variables. Before swapping, the values are okay. Now let's run the program. The values are 10 and 20. Now let's start with method 1 using a temporary variable. It's the most straightforward and safe approach, perfect for beginners and ensures that no value is lost. Let's create a variable called temp and I will assign a to temp. After that, I will assign b value to a. Then temp value to b. So what will happen is, initially a value is 10 and b value is 20. Now we have assigned temp value as a, so temp becomes 10. Then b is assigned to a, so a becomes 20. Then temp value is assigned to b, b becomes 10. Before swapping, the values are 10 and 20. Now let's see what are the values are after swapping. So let's create another print statement same as this. We will just going to change before to after. Now let's run the program. See, before swapping the values are 10 and 20, after swapping the values are 20 and 10. This method is great but uses extra memory for the temp variable. This is not always ideal in low memory systems or tight environments like embedded systems. Method 2 is using only two variables, that is using plus and minus operators. Let's say a is equals to a plus b, b is equals to a minus b, and again a is equals to a minus b. Now let's see how it is going to work. First, a is equals to 10. So 10 plus 20 equal to 30. And in the second line, 30 minus 20 will be equal to 10. And in the third line, 30 minus 10 will be 20. So, so let's run this program. We can see before swapping the values are 10 and 20, after swapping the values are 20 and 10. This method is also amazing, but there is a risk of overflow. If a plus b exceeds the data type limit, you will get the wrong result. This is not suitable for large numbers. Method 3 is using multiplication and division operator. Another trick to swap without extra memory. But there is one limitation. Here a and b values should not be 0. Let's say a is equals to a into b. Next, b is equals to a by b. Next, a is equals to a by b. Now let's see how this is going to work. In the first expression, a value is 10 into 20. So the value becomes 200. In the second expression, b is equals to a by b. So 200 divided by 20, the value becomes 10. In the third expression, 200 divided by 10 equals to 20. Now let's run this program. You can see before swapping the values are 10 and 20 and after swapping the values are 20 and 10. This method is good but fails in one condition if the value is 0 and also prone to overflow when numbers are large. This method is rarely used in production and it's more of a brain teaser than a safe strategy. Method 4 is using XOR operator. Let's say A equal to A caret B, next B equal to A caret B, next again A equal to A caret B. Now let's see how this is going to work. So here A equal to 10 and B equal to 20. So 10 in binary is equal to 1010 and 20 in binary is equal to 10100. In the first expression, 10 cap 20 is going to be 01010 cap 10100. So how did we get it? In XOR, if bits are same, the result will be 0. And if bits are different, the result is 1. So after by comparison of these bits, we can get this answer. The value of this will be 30. Now let's run this program. See, before swapping the values are 10 and 20, after swapping the values are 20 and 10. One of the best advantages, there is no risk of overflow, but there is a limitation. It only works with int and not for float or double. Method 5 is swapping of two numbers in a single statement. Let's say b is equals to a plus b minus a equal to b. So currently a value is 10 and b value is 20. The execution starts from right to left. So a equal to b. So a becomes 20. Then after that a plus b. A plus b is equal to 30. Then 30 minus 20, that becomes 10. So let's run this program. So before swapping the values are 10 and 20, after swapping the values become 20 and 10. So this method is just for fun or showing off cleverness with your friends. This method is highly unreadable and confusing, not suitable for real world coding and can be bug prone in different languages and optimizers. So now you have seen 5 different ways to swap numbers and hopefully understood not just the how, but also why behind each method. These basics are more than syntax. They teach you how the machine thinks, and that's what Scale 1 is all about. Which method surprised you the most? Drop your answer in the comments. If you like this video, hit like, subscribe, and stay tuned.